Hi students, this is your Lakshmi ma'am. In this video, I am going to explain Bridge Course third video. Previous two videos, I have given explanation of introduction of chemistry, matter and what is atom, what is molecule. So definitions including with good examples I had explained. In this video, the brief introduction of atom. What is the shape of the atom? How subatomic particles arranged in atom? All these points I am going to discuss. Briefly I am explaining. Once you start learning atomic structure, 10th standard and 11th standard, so you can understand better. Okay, but most of the students have little confusion starting introduction part like shape of the atom, subatomic particles. So that is why I am explaining briefly. So maybe you like this video. So listen first. Shape of the atom. What is the shape of the atom? First point. Any idea? It is spherical shape. Atom, it is in spherical shape. Spherical shape, point 1. Okay, like this. Okay, now second point here, atom is spherical shape. Atom is spherical shape. Atom having 3 subatomic particles. 3 subatomic particles. Atom contains 3 subatomic particles. Those we call it as protons, electrons and neutrons. Protons, okay, electrons and neutrons. Protons are positively charged. Protons are positively charged. Electrons are negatively charged. Neutrons, neutral it is, no charge, no charge. Okay, now its values and the next one and masses, everything we can learn in the next coming videos. Atomic structure chapter coming days I am going to discuss. There I will give all the points, but here for only bridge course time I am giving the brief explanation. 3 subatomic particles, what I said, protons, electrons, neutrons, right? Okay, now listen guys, atom. So in between center it is positively charged, that we call it as nucleus. See, atom like this, spherical shape. Okay, next another orbit also you can take it. Orbit or also call it as shells. I'll give you explanation. So this is okay. Now look into this. Look into this. What I said guys here. 1 second, let me remove this one. Atom is spherical shape. Center is located. What is that? Center, nucleus, orbits. We have different orbits. Okay. Now come back to this point. This is, I am writing the points here. This is nucleus. Nucleus. Where nucleus, there only we have protons. Even neutrons also surrounded here only. Protons positively charged, and what I said, it is represented by general letter is P. And electrons revolving around the nucleus. See, I am drawing once again here. This is nucleus. Electrons are revolving around the nucleus in circular path. This circular path only we call it as orbit. Orbit also call it as shells. or also call it as main energy levels. So different terms we are using here. This is electrons always revolving around the nucleus. Always revolving around the nucleus. Okay, let me draw this one once again. See this one. This is third orbit. Okay. So first orbit, how many orbits I have drawn here? 3 orbits I have drawn, right? Orbits also called as what is that? Shells. Okay. Now see, these are all electrons. Here electrons revolving around the nucleus like this. Okay, electrons. Electrons. That electrons path only we call it as orbits and main energy levels. So electrons like this, electrons. Okay. Now, next, here center, nucleus, positively charged, protons, here protons also present at nucleus only, center only, even neutrons also present here. Only electrons revolving around the nucleus. Okay, clear? What is the shape of the atom? Spherical in shape. So subatomic particles, protons, neutrons, electrons, how they arranged, clear my point? Okay, now come back to the next point. What is the next point here? Just now I said the electrons are revolving around the nucleus. Those circular paths we call it as, what is that? Those circular paths we call it as orbit. Orbit also call it as shell. Okay, both are same. So next one, shell having subshell. Shell having subshell. Subshell having sub-subshell. Okay, so this sub-subshell only we call it as atomic orbital. Atomic orbital. So atomic orbital means each box like this. Each box capacity 2 electrons, one upward direction, one downward direction. So how we will come to know all the points? We have a rules. Hund's rule, Pauli's exclusion principle, half-bow principle. Coming days I am going to explain. It is there already in our channel. Electronic configuration concept time I had given. If you have any doubts, you can go through the topic. Okay, else you can wait for some days. I will explain. Okay, sub-subshell. See guys, sub-subshell we call it as orbital, atomic orbital. Here, most of the students are confusing. Orbit means main energy level. Orbital, what is orbital? Each box we call it as orbital. Orbit having orbital. Orbital in orbit. Did you understand? Orbit having orbital. Orbital present in orbit. Okay, to understand better, I am giving another example. See guys. Suppose college, where you are studying, college or school. So that is what we call it as orbit or shell. Okay, shell. College, we have different sections, right? Different sections. Those we call it as subshells. Okay, different sections. So next one, so you know, for arranging, what is the students for sitting, what is that next one? Benches. Arranging benches. The benches only we call it as subshell. Okay. Now after that we are finally who is that? Definitely student. Okay. This subshell it is bench like this. Okay. Student 1, student 2 sitting like this. So finally the last one is student. So electrons. So we are arranging electrons like this. We are following here 3 rules. Pauli's exclusion principle, half-bow principle and Hund's rule. So those already had discussed. If you need, go through the video electronic configuration in our channel. Okay, so this is introduction of atom. Okay guys, now next one I am going to explain to understand better this one. See, suppose the most familiar example, common example, carbon. Carbon, how we are representation? See, generally elements we are representing like this, X, Z, this is A. Next video I am going to discuss atomic numbers, everything. There you will understand better. So here Z equal to atomic number, A equal to mass number. So now I am writing atomic number of carbon 6. It's exactly double mass numbers. Students, easily we can remember towards examination. So atomic structure we have numericals. In that numericals they are asking you to calculate number of electrons, protons, neutrons and mass number, everything they will ask. So up to 20 elements easily you can remember, just you can double. Yes, double, more than double. You can remember like that. Next video I'll give the table. So next, just a simple point only I am giving to understand this above concept. Carbon, atomic number 6 and mass number 12. Here what is Z, students? Z equal to 6. And what about A? A equal to 12. Now let me write. In neutral atom, your atom is neutral. See, this carbon is now neutral condition. So see, nitrogen is neutral condition. Now nitrogen, suppose like this. This is charged species. This is, we call it as anion. Suppose sodium, this is neutral atom. Sodium plus, this is, we call it as cation. This is neutral atom, this is cation. This is neutral atom, this is anion. So what I am trying to say here, see, in neutral atom, so Z equal to protons and electrons. What is the Z value? That is number of protons, number of electrons. Clear? Now, how to calculate next part, neutrons? Very simple. A minus Z, 12 minus 6, 6. So, like this we will get competitive questions. One particular element X having atomic number 6, so and so, they will give. And atomic mass, sometimes they may not give. We have to remember, and finally we have to calculate protons, electrons and neutrons. Hope everybody understood this video. So please give comments and likes and share to all people. Thank you students. Thanks for watching.